Welcome back, students, to another video of Prestressed concrete. In this video, we are going to understand uh, how statically indeterminate prestressed concrete members work. Okay, so up to this point, we have learned analysis of stresses, deflection, everything that are applicable to any determinate structure, right? So we have not touched yet any indeterminate member. So, but in real life, as we already know that most of the members that we deal with are either fixed beams or continuous beam, right? So it is of paramount importance to understand the mechanics, the physics, the stresses, the moment, shear force that generate within indeterminate prestress member when it is subjected to prestressing force and external loads, and ultimately uh, how it pans out, how is it different from the determinate structures and all, right? So usually there are few benefits of using indeterminate structures, right? So let me just, yeah. So obviously in case of when we use indeterminate structures, indeterminate members which are prestressed in nature, usually the bending moments are more evenly distributed between the center of span and the support members. As a result, since the bending moments is distributed, uh, the size of the section reduces, uh, and ultimately the load carrying capacity is also higher when you compare with statically determinate structures of same dimensions, right? So there are many disadvantages like this. Now, how am I saying that the bending moments are more evenly distributed, right? So we have to go to the next slide to understand that. So what actually happens if you look at this diagram here, the beam is supported on three hinges, right? So usually up to this point we have done a simply supported beam which usually deals with support A and support C. There is no support B there, right? But since we are dealing with indeterminate members, so we, in this case it is considered that it's a continuous beam, right? So that's why there is a support B at the center as well. So the beam has three support and it's a continuous beam, right? So if it would have been a simply supported beam, in that case, if we applied P prestressing force, in that case, what will be the deflected profile considering it being a simply supported beam? It's shown here, right here, right? It would deflect like this only if there was no support B present. All right. So the moment that is happening there is completely hogging moment, right? But if there is a central support V present and in actual it is a continuous beam, in that case obviously the beam is not allowed to shape like that. The central portion will be brought down by the support V, and there a reaction R will be acting downwards to keep it down. So if you notice carefully, near the support A and the support C, towards the central support, we observe a hogging shape, hogging moment being present there, and there is a sagging moment is also present. So this sagging moment that is present here is due to the presence of the central support, that is B point. The support being present here, it happens like this. So in general, if the support was not here, the deflected profile would be like this. And since the example is more of a eccentric cable which is constant throughout the span, the bending moment which originally occurs, right, that is PE throughout. P is the prestressing force and E is the eccentricity from the neutral axis. So the bending moment obviously will be like we learned while calculating deflections. Uh, Similarly, we can also find the bending moment will be of a rectangular shape, right? And the magnitude will be constant, that is PE. And since a hogging moment, the sign would be negative, right? So that is called the primary bending moment, which is caused due to the application of prestressing force, considering it as a statically determinate structure. Now, since there is a central support B, right, and the structure becomes indeterminate, so it no longer follows the same deflected profile as before, right? So due to this incorporation of this new support, there is another moment that is present which causes actually this sagging part, and that is called the secondary moment, right? So we understand that due to the application of pre-stressing, there is one moment that is generated initially that we call primary moment, bending moment. And when my structure becomes indeterminate, due to the indeterminacy, due to the added constraint, due to the added support, there is one additional moment that is created, which is as here, which is mentioned as secondary moment. So this secondary moment is actually the moment which is created due to this support only. And say the support is having reaction R, it is having a reaction R to keep this beam down to its level. Obviously, if you say the length is L from here and L from here, the total length of the beam originally would have been 2L. And if there was a load from the central point, say P, we already know the bending moment diagram for such a loading condition is a triangular one, and the magnitude, maximum magnitude of the bending moment will be under the load, and that is given as PL by 4, right? So in this case, your L is 2L, the total length is 2L. So in place of P we have R, in place of L we substitute by 2L and divided by 4. So that becomes ultimately RL by 2, right? So that is how you obtain the secondary moment. All right. So this is the basic concept. What is primary moment and what is the secondary moment due to the added redundancy. So in this chapter, what we are going to learn is basically how to find out the secondary moments. First, we have to find out the primary moments due to the prestressing force, and then how to find out the secondary moments, right? And then obviously there will be some added load on top of the beam, and then you have to also calculate uh, the moments at different points, right? So since we're dealing with a continuous beam, obviously you must know how to calculate the moments in a continuous beam. You can easily apply three moments theorem that you have learned in earlier semesters. So it's quite simple using a three moment theorem. In case you have forgotten, you can simply just recapitulate the method